Hi guys, this is O-Level Chemistry, paper 11, June 2020, question 21. Which aqueous reagent liberates ammonia from ammonium nitrate on warming? So ammonium nitrate is an acidic salt and its formula is NH4NO3. So in order for this to liberate ammonia, this should react with a base. So the options we have are calcium nitrate, which is a neutral salt, so this won't happen. Potassium hydroxide is a base. Ammonium nitrate will react with potassium hydroxide, producing potassium nitrate and water as salt and water and releasing NH3 as the gas. So potassium hydroxide is able to carry out this reaction because a base will react with a weak acid, which is ammonium nitrate salt. Next option is sodium chloride, which is also neutral, so no. And D is sulfuric acid. Sulfuric acid will not react with the weak acidic salt to liberate ammonia. In fact, if ammonia was present when sulfuric acid was there, it would have reacted with it, forming ammonium sulfate. So the correct option for this question is option B. Question 22. Which statement about sulfuric acid is correct? It is manufactured by heating hydrogen, oxygen, and sulfur together. No, this is not what happens in the contact process. It is used as a battery acid. Yes, car batteries have sulfuric acid as the electrolyte. It is used as a detergent. No, this is a very strong acid. It is used to neutralize alkaline soils. No, we will not be using sulfuric acid for this purpose. It would leach up the minerals present. So the correct option for this question is option B. Question 23. The diagram shows part of the periodic table. Which element has the highest proton number and which element has the largest number of valence electrons? Okay, highest proton number would be the element that is at the bottom of the given part of the periodic table, which is calcium. So either A or B would be the answer. And the one with the maximum number of valence electrons would be chlorine, the one to the right. So the correct option is there in B and not in A, making option B the correct option for this question. Question 24. A lump of element X can be cut by a knife, and during its reaction with water, X floats and melts. Both of these properties belong to group 1 metals. So, what is X? X cannot be calcium because calcium belongs to group 2. Copper is a transition element. Magnesium again belongs to group 2. Potassium belongs to group 1. So, this makes option D the correct option for this question. Question 25. Which statement about the properties of some elements is correct? All noble gases are unreactive due to having 8 electrons in their outer shell? No, because we do have a compound called xenon tetrafluoride. So, noble gases can be made to react. Next, the group 7 elements acetylene is expected to be a black solid at room temperature. The element above acetylene is iodine, and iodine is a blue-black solid at room temperature. So acetylene will be a darker color. So yes, black solid at room temperature it is. The reactivity of the elements in both group 1 and group 7 increases down the group. No, reactivity decreases down the group. So this becomes incorrect. D. When aqueous chlorine is added to aqueous potassium bromide, there is no change in color. No, aqueous chlorine will displace bromine from potassium bromide, producing aqueous bromine, which is a orange brown liquid. So this is the reaction that will happen. So this says no change. So this makes this point incorrect. So as a result, the correct option for this question is option B. Question 26. Which diagram shows the structure of an alloy? An alloy would have different size of atoms arranged in a lattice. So A has different size of atoms arranged in a lattice. A is the structure of an alloy. B is the structure of graphite because it is occurring in layers with intermolecular forces between them, represented by dotted lines. C is the structure of an ionic lattice. That is why it has such a regularly arranged structure. And D is the same size of atoms next to each other. This is the structure of metals. So the question asks the structure for alloy, which makes option A the correct option for this question. Question 27. Which element can only be extracted from its ore using electrolysis? A highly reactive metal can be extracted from its ore using electrolysis, and usually the ones that are more reactive than hydrogen and in some cases iron. So here we have got calcium, which is a highly reactive metal. We've got copper, which is less reactive than hydrogen. We've got lead, which is more reactive than hydrogen, but less reactive than iron. And then we've got silver, which is less reactive than hydrogen. So the most reactive element here is calcium. So calcium will be extracted from its ore using electrolysis, making option A the correct option for this question. Question 28. The equations show reactions taking place in the blast furnace. In which reaction is an acidic impurity present in iron ore removed? Okay, so the acidic impurity present is SiO2. So in A, carbon reacts with oxygen to form CO2. This is a combustion reaction. So there is no acidic impurity being removed here. B, carbon plus carbon dioxide gives carbon monoxide. This is carbon dioxide undergoing reduction. So there is no removal of acidic impurity from iron ore. Fe2O3 plus 3CO gives Fe plus 3CO2. This is how iron is extracted from its ore hematite. There is no acidic impurity being removed here. And the last one, CaCO3, which is a basic salt, reacting with SiO2, which is the acidic impurity present. This reacts to produce CaSiO3 plus CO2. So this is the reaction in which an acidic impurity is being removed from the iron ore, making option D the correct option for this question. Question 29. Which diagram correctly shows the conditions necessary for the rusting of iron and also the metal that can be used to prevent rusting by sacrificial protection? Okay, first of all, rusting of iron is because of oxygen and moisture in air. So options A and B only represent oxygen as the condition for rusting. This is not true. Oxygen along with water vapor is the required necessary condition for rusting. So options C and D remain, A and B have been eliminated. Next, for sacrificial protection, the metal used should be more reactive than iron because we are protecting iron. So it should be more reactive than iron so that it reacts with oxygen and water vapor and prevents iron from reacting with them. So in option C, we've got copper, which is less reactive than iron. So this will not protect iron from rusting. Iron will rust in the presence of copper as well. And in option D, we've got magnesium. Magnesium is more reactive than iron. When oxygen and hydrogen are exposed to the metals, magnesium will react with them, forming magnesium salts, while iron will remain protected. So this makes option D the correct option for this question. Question 30. In the electrolysis of molten aluminum oxide, which statement is correct? The molar ratio of aluminum to oxygen gas is 1 is to 2. Aluminum has a charge of 3 positive, oxide has a charge of 2 negative. Aluminum would be requiring 3 moles of electrons to produce Al, and oxygen would be requiring, or rather releasing, 2 moles of electrons to form O2. Actually, one oxide will remove 2 electrons. So 2 oxides will remove 4 electrons. So let's fix the molar ratio here. We would have 4 moles of electrons being released to produce oxygen gas. So now the ratio is 3 is to 4. In order to balance that, the ratio of aluminum to oxygen is 1 is to 2. No, this would be multiplied by 4. This would be multiplied by 3. So we end up with 4 moles of aluminum being produced along with 3 moles of oxygen gas. So 4 is to 3 is the ratio, not 1 is to 2. So this option is incorrect. Next, the molar ratio of aluminum to oxygen gas formed is 3 is to 4. Aluminum is 4 and oxygen is 3. It is not 3 is to 4. It is 4 is to 3. So this is incorrect as well. Oxygen gas is formed at the anode. Yes, oxygen is formed by oxidation. So oxidation takes place at the anode. Reduction occurs at the anode? No, reduction occurs at the cathode. So this makes option C the correct option for this question.